Hey guys, it's Logan again. Welcome back to another video on creating a maze generator in Gamemaker Studio 2. So in the previous video, we did a slight overview of a couple different data structures as well as the graph traversal method that we'll be using for our maze. And once again, here is the maze. I actually did a slight alteration. I wasn't getting the effect I wanted before. So this should look actually a bit better, more like a maze. Before I had something wrong in the code that was making the lines perpendicular to the player always blank, and this is more mazy-like. So you can see I have the a full maze now. You can walk around this entire map, and it's guaranteed that you can always get to anywhere on this map. So it looks really, really good. If I do 400, it'll be a bit more fleshed out. Maybe let's try 500. Obstacles, and let's see, and you see it's starting to really close off, but it's still accessible. It's a full map. It looks really, really nice. Okay, so this time in this video we're going to be creating a system to store coordinates, and I know that sounds kind of silly, and what do I mean? Okay, so wouldn't it be nice if we could iterate through a list, and for each position in that list it had an XY coordinate representing that position? And what do I mean by this? So let's say this is our list, and these are our indexes, 0, 1, 2, 3, 4, 5, 6. What if we wanted to store two values in here, x and y? Well, we can't store two values in a single place, and this is a limitation from by Gamemaker that we have to kind of work around. We're actually going to be using a 2D array structure type thing. And if you want to read more into how that could kind of be used, I'm going to put a link in the description below. GM Wolf has a tutorial outlining how this can kind of work. And if you're still a little bit confused, I'll kind of explain it a bit better in this slide. Oh, I didn't even turn on my PowerPoint. Whatever. So you see here, maybe we want to store an X and Y coordinate into an array. Into a one-dimensional array or a list. In our case, it's going to be a list, which is basically a one-dimensional array, okay? We'll just think of it as that. And I want to store two coordinates in that list. How do we do that? Well, we really can't unless we create an object in Gamemaker, and we could create an object called coordinate and store XY values. But the thing is we're going to be making quite a few coordinates, over 100 coordinates. So the thing with a Gamemaker object is it stores so much data. It has image angle, image speed, image index, X and Y values, image blend, image angle, I already did that, and there's all kinds. You know what I'm talking about, is all those built-in variables that it has, X speed, Y speed, gravity. All those are built in, and all of those eat up memory. And for each object that we create, all that memory is taken up. And if we create 100, 300 of those objects, that's a lot of memory that is being eaten up just by needing to have two integers stored, an X and a Y value. So what we're going to do to fix this is, first I'm going to give you a demonstration of, in another language like Java, how this could be done and not eat up a lot of memory and be really easy. So I'm going to open up Java. Don't worry about understanding all the code. Basically, I just have a class. This main method is kind of the starting point of the program. This is what the program starts from. So don't worry about the syntax and all that stuff. So like I said, we want an array that we could store two things in, okay? Well, in Java, you could make a simple class and call it, or this would be like an object in Gamemaker, right? Class, I'll call it Chord for coordinate, okay? And all I have to do is, don't worry about public and all that. I'm not going to explain that stuff. Don't worry about it. Public basically means that anyone can access this variable. And I have to initialize as an integer. We don't have to do that with Gamemaker. Public int y. All right, that's it. That's it. Now we have a coordinate. We can store a coordinate object inside of an array. And this coordinate object will contain an XY value. But in Gamemaker, we create an object, like an object in game, and we give it an XY value. It also makes variables like public int image speed, which they're actually doubles, public int image angle, public, and the list goes on. I don't know. I don't know exactly how many variables are, but I think there's around 100, maybe more than 100 variables built in, and all of these take up memory, and a substantial amount of memory for Gamemaker, 16 bytes per variable, 16 bytes per variable, and in comparison, an integer here only takes up 4 bytes, so you're talking about 4 times more per variable in Gamemaker, and there's 100 of these, so that's a lot of memory eaten up just from having an object that can hold these two values. So in Java, you create your Chord class, or in C++, you could do a struct, which is a structure. It's kind of the same thing. Don't worry about it. And let's say I wanted to store a list of these coordinates. So I could do, I'll just make an array. I'll call it, this is how you initialize arrays in Java, Chord. It's an array. We say it's going to be an array by using the brackets. And I'm just going to list it as chords. And I'm going to say equals new chord. And then I give it a size. Don't worry about the new keyword either. I give it a size of, I'll just say 10. Okay, and then I have to initialize the array. Right now it's not initialized, so, and I'm just going to say what each of those positions are. Equals new chord. Okay, so don't worry about it. I'm actually going to set these to default. Each coordinate is going to be at 0. Okay, so right now I have stored in our array a chord object, and to access these I could do system. I'm just gonna, this is doing a show message kind of, well, show debug message really. System.out.print line, and I'm gonna say x. I'm gonna print out the x and do chords 0.x plus y plus chords 0.y. All right. And right now it's going to print out 0, but I can set a coordinate for a specific coordinate by doing chord 0 index dot x equals 10, and chords 0 dot y equals 100. Now if I print this out, it will actually, down here, you'll see 10 and 100. X 10, y 100. It printed out my coordinate, right? And if I were to do a for loop, I'll just do real quick. Don't worry about what I'm typing here. Temp chord. Okay, so this is just going to print out all of our coordinates. You see, they're all defaulted to 0 right now, okay? Besides the first one, because that's always set here. But you see that in a one-dimensional array, I can set 2 values by using this system. I can actually keep going. I go public string name equals hi, right? And then I can do plus temp chord dot name. And then I can run it again, and you'll see down here, if you could see it on your screen, it's printing out hi at the end of it, because we can store so many variables in these. We can get the same effect with objects in Gamemaker, but again, the objects in Gamemaker eat up a ton of memory. This does not eat up a lot of memory. It just has a few simple variables, okay? And I think another 4 to 8 bits that are, or no, 4 to 8 bytes for being a new object, and that's about it. So this is not taking up much, maybe around, this might be 16 bytes actually total. And in comparison to one variable in Gamemaker being 16 bytes. So you can see that this eats up a lot, and I spent too much time kind of explaining this, but basically we want to store 2 values for one position in an array. So that's what we're going to set up today. And we can do this by, we're going to create kind of something to interface with called, you'll see here we have a create chord list, add coordinate, get coordinate, shuffle chord list, display chord list. And these, you'll see we don't actually, in our main code, we aren't even messing with 2-dimensional arrays. We're just saying create coordinate list, and then we're saying add coordinate. We're giving it an x and y coordinate to add. And then we're saying get coordinate, and then we're getting a coordinate from a specific position in our array. And so you see, I want to return the x, that's what it's going to return. And I do the same thing here. I'm going to increase this. I want to return the y, and that's what it's going to return. So I know this might be a little bit confusing, but let's just start a new project, and I'll explain as we go. Okay, so I'm going to go to, I need to open up Gamemaker, create a new project. I'm going to go ahead and skip. All right, so we're here. The first thing I'm going to do is just create an object. Don't even need a sprite yet, and we're going to call it maze_generator. Okay, and let's call in its create event. This is where we're going to do our code. So I opened up its create event, maximized it, initialize room, and I'm just going to call a script called initialize room here, and then we're going to create that script and do everything in there so we don't have to interface with this object so much. So initialize room, and we're going to create a script called that, and I can close the object out, go to our scripts, and rename it to initialize room. Awesome. Okay, so what's the first thing that we want to do when we initialize our room? Well, we need to make our coordinate system that we could store coordinates in. So we're going to call, I'm just going to comment this in, initialize coordinate list, and that's what we're going to do. So we're going to say initialize chord list. Sure, that makes sense. Initialize chord list. Okay, and I'm going to make a new folder under our scripts and call it coordinate structure. This is going to have all our coordinate functions, and let's create a script, and I'm going to call it initialize coordinate or chord list. There we go. And this should turn yellow now. I'm going to go ahead and close that out. Okay, so what do we do in initialize chord list? Well, the first thing that we're going to do is set our current chord list size, right? So this is going to keep how large our array is, okay? And we're just going to set to 0. I'm using underscore because we're inside of a function that we're not going to access a lot, so we kind of want to name it differently than we might name something in the rest of our code. And let's initialize our array. We're just going to call it chord equals, and then we do a bracket to give it an array, basically. And we don't know the size, so we aren't going to reserve any space. It'd be faster to reserve space if we knew the size, but for now we won't. Maybe we'll add that in later. And we're going to create 2 macros, okay? And macros are basically, they're constants. And how you initialize them is the number sign, macro, the constant name, and a value, okay? So now anytime we use the letter X, it's going to mean 0, and the letter Y is going to mean Y, okay? So this is how we're going to, inside of our chord, like if we were to get a value, we could say equals position, and then X, because we want to get the X value of that coordinate, or if we want the Y value, we're going to use Y, okay? And that's why this is easy to read and understand, okay? And that's it for initializing our chord list. So I'm just going to do an @description and init our chord array. Initialize our coordinate array. Awesome. So now what's the next thing that we want to be able to do? Well, we want to be able to add a coordinate, right? So let's create a script and call add coordinate. And there are ways that we could make multiple of these systems, but I'm simplifying this. We're only going to use the one coordinate list. We don't need multiple coordinate list structures, so that's why we're just doing this. And we're making these scripts so when we're writing the rest of our code, we don't have to worry about what the array name was or any of that. So we make add coordinate, get coordinate, and that's all we need to call. So how do we add a coordinate? Well, it's pretty easy, really. We say chord, this is remember our chord array name, and at our chord list size, remember it's 0 right now, so at 0, and at our X value, we can take in an argument. We can use argument 0, okay? And same thing for the Y. Chord underscore chord list size Y equals argument 1. So we're going to pass 2 arguments into our script, and it's going to add a coordinate for us. And I will show you, we could do this. chord list size plus equal 1, but you can use inline here, and we can do plus plus after this and get rid of this, and it is the same thing. It's going to increase our coordinate list size after this is finished. So what's the difference between plus plus and plus plus before? Well, in this case, it's actually going to increase this value before the rest of this code, or this code is complete. So this would actually be 1. It'd be like saying this, and this would be 0. Okay? And that's not what we want. But if we put the plus plus after chord list size, it will assign this argument to 0, and then it's going to increment chord list size after that's already finished. So we can do this inline, and 2 lines of code, we have our add coordinate. And we're going to write some descriptions. So we're going to use at description, and we're going to give it a description. Add a coordinate point to coordinate list. And I might need to increase the font size here for you guys more. And we're going to also add 3 dashes at param. Param is a parameter, and what's one parameter? It's argument 0, and that's our x value. And our second param is going to be our y value. Awesome. So now we have our add coordinate and initialize coordinate list, okay? Now, if we go back to our initialize room, we initialize chord list, we can now add coordinates. I can say add coordinate, and you see why we did the param. It's going to pop up in our function and tell you exactly what's needed, especially down here. So you know it's our x and our y value. So we're going to add 10 and 10. And that is going to be added to our coordinate list. Awesome. So how do we retrieve a coordinate? Well, super easy. We're going to create a new script and call it get coordinate. And we're simply going to type return chord and argument 0, argument 1. And that's going to give us a specific coordinate. So this is going to be the position we want to get the coordinate from in our list. And this is going to be, do we want the x or the y? So I'm going to kind of type this out up here. I'm going to do a description at description and return the x or y value at a position in our coordinate list. Okay, and then it's going to take in 2 parameters. Our first parameter is position of coordinate to retrieve in our array, okay? And our second parameter is going to be x or y, and that's going to be which value to return. Awesome. So now we can go back. I'll give you a second to pause there. This is all you need. 3, 2, 1. And I'm going to go back to my initialize chord list. Initialize room. And let's add 2 more coordinates. And let's change the value to like 20 on the x. I'm just going to change it to 20 and 15 and 30. So our coordinates are all different now. And to get a coordinate, we could use get coordinate. I'm going to use show message to demonstrate how this works. So I'm going to use show message, and we're going to show our coordinates. Let's show our second coordinate that we entered. Show this one. Well, we know this is at position 1 in our array because this is at position 0, right? Okay. So I can use show message string get. I need to use string to change an integer value into a string or a double. And get coordinate and what position? Well, I want to get it from 1, and what value do I want to get? Well, let's get its x. So that this should return 20 if we did everything correctly. So let me add my object to my room and go back to my workspace. And remember, this is in our initialize room script. And if I hit play, it should show us 20. And there it is. It gave us that value. And if we want the y, we simply do y. and that should show us 15. Now, you could say it's kind of hard to keep track of where we want each individual coordinate, but in our system, it doesn't matter where the coordinates are. What we're going to do is add each coordinate in our grid space. So if I were to open my other project and I run the game, I give it 150. We're adding each coordinate, each grid coordinate. So this is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all the way across. And then 1, 0, 1, 1, 1, 2, 1, 3, all the way across, and it goes all the way down. So every one of these boxes is a coordinate in our list that we're going to have, okay? So what we're going to use is we are going to add a coordinate for each box or each grid space, okay, all the way to the bottom right of our room, which is going to be quite a few coordinates. And then what we're going to do is shuffle our array. So originally we have all of these coordinates in order, and we're going to shuffle that around. So maybe this coordinate down here now is going to be the first one accessed. And then this coordinate right here will be the second one accessed. And then we're going to run through one by one, since they're all shuffled now, and try to add objects to those coordinates. And I know that sounds a bit confusing, but what that does for us is allow us to sequentially run through our array, trying to add coordinates to each space. And we can use a stack data structure for this if we want, okay? And or a queue, we can use either one. So we'll see what we're gonna do in this example. But the big thing to remember is it doesn't matter to us what order the coordinates are on. What order the coordinates are in, as long as we're able to add them and access them by using an array index, a one-dimensional array. Well, we're using a two-dimensional array for this, but like I said, in our Java example, now we could do, so let's say we're adding these all to a list, right? And now we can use a for loop. I'm gonna use I equals 0, I is less than, we don't have a get coordinate list size yet, so we'll just use, we just know that we have 3 values. So I plus plus, I think I need to use I less than 3. And I'm gonna print out each coordinate. So I'm gonna use I and print out the X of each coordinate, okay? Just for simplicity. And it should run through all of our lists. So we have our first X, our second X, and our third X. And that's it. So you can see we can loop through each coordinate and get the X and Y values. If we wanted the second value, I can do plus, and then just copy paste this, plus, and use Y instead of X. And this will print out the X and Y coordinate of each coordinate. So we have 10, 10, 20, 15, 30, 12. And I hope that makes a little bit of sense. And if not, don't worry about it. Keep following along. It's going to start coming together, okay? Don't get discouraged if it's not coming together how this is going to work out, because it is kind of weird that I'm showing you in this order, but there is a reason that we need to have these coordinates set, okay? And that'll kind of come to fruition in the next video or two, okay? So I hope you learned something and enjoyed this video. And again, give GM Wolf's video down below a look, and he kind of goes more into how you can create these structures using two-dimensional arrays as well. So I will see you in the next video, and thanks for watching.